We're starting a new chapter, and it's a really fun one. Some of you did a density experiment yesterday, which has to do with this chapter and the properties of matter. A lot of things I want to stop and say and explain, but to keep this video short enough so that it will post, I'm just pretty much going to have to read with you, and we'll talk about some of these things at our Zoom meeting. One way to describe matter is to list its physical properties. A physical property is something you can measure or observe about matter without changing its identity. Describing physical properties helps tell us what matter is like. Many physical properties can be observed simply by using your senses: color, odor, taste, shape and texture, or touch. The table below summarizes many of the physical properties of the frozen fruit pop in the picture. How do you think the properties might be different after an hour? Other physical properties depend on how matter behaves or acts under certain conditions. Magnetism is a physical property that describes how an object reacts to a magnetic field. A magnet is an object that produces its own magnetic field. Objects that are magnetic are attracted to a magnet, and you will learn more about magnets in Chapter 11 when we get to play with them some more. Yet another physical property is malleability. Malleability is a measure of how easily the shape of a substance can be changed when it is hammered or bent. Gold and lead are malleable. They can be pressed into thin sheets without breaking. A substance that is not malleable, like glass, is brittle or may break easily. You can look at the pictures and read the captions. I have to keep moving or this gets too long. Measuring matter. The International System of Units is used in fields relating to science and industry. In science class, you will use metric units of measurement. Some properties of matter can be measured using tools. These properties are summarized in the table below. You'll see those. An object's volume is the amount of space it takes up. Volumes of liquids and powders are measured with measuring cups and graduated cylinders. We'll talk a little bit about those at Zoom class. These tools measure volumes in liters or milliliters. You can find the volume of a block of wood by multiplying its length, width, and height. The product is the volume of this regular solid. You can find the volume of irregular solids by measuring the displacement of water. This refers to placing the object in a liquid and measuring the difference in the liquid's volume. And this Explorer Lab will do that during our Zoom. Think about properties you can observe or measure. Some physical properties depend on the amount of matter in the sample that you are studying. Mass and volume are examples of these kinds of properties. While all matter has mass and volume, they cannot be used to identify a specific sample. Other physical properties of matter do not depend on the size of the sample. They are properties of a particular kind of matter. They help you tell one kind of matter from another. Some properties of different kinds of matter are listed in the chart. You will learn more about them later in this chapter. We have color and density and melting point and boiling point. All of those are cool properties. Again, the purpose of this recording is just to read along with you, and then we'll talk about and explain some more later. Otherwise, our recording gets too long. Remember that matter is anything that has mass and volume. You can use those two properties to find the density of a sample of matter. Density is how much mass is in a certain volume of matter. It lets you compare different kinds of matter. For example, suppose someone asked you, which is heavier, lead or gold? The answer would depend on how much lead and how much gold you had. You can compare them only if you have equal volumes. So the question should be, which has a greater density, lead or gold? You will answer that question in the math and science below, and we'll take a look at that in Zoom. Have you noticed that you feel lighter in water than you do when you climb out? When you're in water, the water pushes upward on you. All liquids, not just water, push upward on whatever substances are in them. Buoyancy describes this upward push. It makes some objects and other liquids float in water. If the upward force is greater than the weight of an object, the substance will float. If the upward force is less than the weight of a substance, the substance will sink. Buoyancy and density are related. You can use density to predict whether an object will sink or float. If a solid object has greater density than water, it will sink in water. If an object has a lower density than water, it will float. This may look familiar to some of you who did one like this yesterday. A substance or an object will float in a liquid that has a higher density than it does. The substance or object will sink in a liquid that has a lower density than it does. Liquids with different densities can form layers. A density column, such as the one shown in the graduated cylinder here, forms with liquids of different densities. The blue water is the most dense, and it sits on the bottom. The oil, yellow, is less dense than the water, so it floats on the water. The rubbing alcohol, red, is less dense than the oil, so it floats on top of the oil. Both liquids float on top of the water. So again, this recording is just to read through our chapter. It's fascinating. Check out some additional things in the chapter if you have time, and we'll look at some of these specific things that I've had to skip by at our Zoom class